This lesson is on multiplying and dividing fractions. Here are the steps. In order to multiply a fraction, it is really important that you change your mixed numbers into improper fractions. You have to do that in step 1, otherwise the whole process won't work. A lot of people are fans of cross-canceling, so you're going to look for common factors, and you're going to cancel one numerator and one denominator. You can either do what's called cross-canceling and have them literally across from one another, or you can cancel up and down as well, which is just simplifying fractions before you multiply. So with canceling, you're looking either across or up and down, but it's really important you use one numerator and one denominator. Then you're going to multiply the tops, multiply the bottoms, and if you've already properly cross-canceled, you should not need to simplify unless you want to change it into a mixed fraction. If you are fearful that you did not cross-cancel correctly, or you never bothered to check, then you will need to spend more time on step number 4. So let's try some of these. They just say simplify. It looks for them like the most part 1 through 8 has multiplication times dots. So in the first one, I'm going to use cross-canceling, so I have to make sure I have one numerator and one denominator, and 2 goes into 2 one time and 2 goes into 12 6 times. I'm left with 5/6 times 1/9, and then as the steps described, I'm multiplying the tops. 5 times 1 is 5, and then I'm multiplying the denominators, and 6 times 9 is 54. And there are no common factors between those two numbers other than 1. On the next one, I notice they're trying to trick me. I have a mixed number, so I'm going to multiply here, and then I'm going to add as I go to the numerator. So 1 times 2 is 2, plus 1 is 3/2 times 2/3. If I forget to cross-cancel, or I don't like doing it for some reason, I can just multiply the tops, multiply the bottoms, but then I'm going to have to spend some time simplifying in the last step. So that comes up to give me 1. That's why a lot of times people like to cross-cancel, because then you get smaller numbers when you're multiplying, and then when you multiply, you're done. And a negative times a positive is a negative. So at this point, since I correctly cross-canceled, I don't need to bother trying to simplify anymore. Here I go again, changing a mixed number into an improper fraction. 4 times 2, 8, plus 1 is 9 over 2, times, remember your denominator stays the same when you're changing it to an improper. 3 times 3, 9, plus 1 is 10. Remember, I don't need to get common denominators. I didn't point that out yet, but I do not need common denominators when I'm multiplying. 2 goes into 2 one time, 2 goes into 10 5 times, 3 goes into 3 one time, 3 goes into 9 3 times. And then you can either rewrite your fraction like so, or you can just carefully multiply all the remaining parts, which gives you 15 over 1, which needs to be simplified down to just the whole number 15. Number 5, I don't see anything I can cross-cancel, so I'm just going to multiply across 4 15ths. That one's really simple. Number 6, and notice I have those mixed numbers again, so I'm going to just change these. 1 times 3, 3, plus 2 is 5/3, times 12 plus 1 is 13. And again, I don't see anything that cancels here, so 60, 5 times 12 is 60, plus another 5 for 13 is 65 over 12, or, in box this, 5 and 5/12. We talked about exponents last chapter, so this means I'm going to take this, put it in parentheses, since that's how it's written originally, and multiply it by itself twice. Then I'm going to multiply the tops, the bottoms, and a negative times a negative is a positive, so 4/25. This one, same idea. One of the mistakes that people make is when they change a mixed number that's negative into an improper fraction, they do some goofy stuff. So it's just going to be negative, and when I'm actually changing this, I can almost just ignore that it's not negative. So 4 times 3 is 12 plus 1 is 13/3. Now when I'm dealing with this problem, I do have to then go back and imagine it is negative. But notice how when I do 4 times 3 plus 1, I'm actually adding them even though it's a negative. And I slap the negative back on. I look for things to cancel. I multiply across tops and bottoms, and I get 26/1, which is just 26, and it's a negative times a negative, which is a positive. Next up is number 9. Here we have some variables. So let's start with actually the numbers. 3 goes into 3 one time, 3 goes into 6 2 times, n goes into n one time, n goes into n one time. I can cancel those. Then I'm left with 5 times 1 times 1 over 2 times 1 times 2, which is 5/4, or 4 goes into 5 one time with 1 left over, 1 1/4. Next up is dividing fractions. One extra step when dividing, which is step number 2. Before we get to step number 2, step number 1, I want to change everything to improper fractions if they're not improper fractions. Then I want to change division to multiplying by, this is a typo, by flipping or taking a reciprocal, it's a typo as well, second fraction. Then I'm repeating the same steps. These are all the same steps that I was doing before. So this is why multiplying and dividing is much better than adding and subtracting. I don't need common denominators, and dividing problems I just change into multiplication, which means I just repeat the same steps. So it's always the second fraction that you're going to flip. So 4/5. The other important thing is you have to change this to times. So I change it. To justify that change, I need to flip the second fraction. Then I'm looking for things to cross cancel, and I'm multiplying with the leftovers. So 6/5. Or 1/5. 1/5. Before we do any flipping, I'm going to fix this. Remember this negative, I can ignore it for a second. 3 times 5 is 15, plus 3 is 18/5. Now bring down the negative. Let's go slowly. Let's just first keep that the same. Then we can flip. Then we can look to cancel. I think that's it. I'm going to multiply across and watch out for that right there. So I've got 21/5, which is negative. 5 goes into 21 4 times with 1 left over. Here's the mixed number version. I did this earlier. I dealt with a whole number. I didn't say much about it, but maybe you figured it out. All I need to do is take whole numbers and put them over 1, change division to multiplication, and flip. (15) or 15/1, but 15 is the best answer, most simplified. Last couple. Don't cross cancel until you flipped. Not seeing anything to cancel, so 5 times 4 is 20, 3 times 9 is 27. Another good idea when you're working through the problems is maybe predict whether it's positive or negative, and then go to the side and do the work so you don't forget the sign. 3 goes into 26 times, which is 18, so I have 2 left over, and it's negative. So this will be my final answer. Number 10. Change both fractions into improper fractions. Then flip the second fraction. Change division to multiplication. Then look to cross cancel. I'm not seeing anything to cancel. 64 over 27. 27 doubled is 54, which means that there's 10 left over out of 27. Last one for the day. Right away, I'm going to flip. And I'm going to look for things to cancel. 3 goes into 3 one time. 3 goes into 9 3 times. You could also choose to cancel the 3 with the 6. You'll end up getting the same final answer. So it's whatever you spot first, as long as you're canceling one numerator and one denominator. Then I've got 18, the variable is CAT, over 5 CAT. Maybe you already did this, but I'm now going to cross these off. I waited to do this. So my final answer will be 18 fifths, or 3 3/5. So that was a lesson on multiplying and dividing fractions.